Hey fellow YouTubers, this is N0AGI. I'm here to do a multi-part project video. So I've always been very interested in 3 degree of freedom motion simulators, and I tried different routes in the past, meaning I tried electrical, digital servo-based motion. I tried just a regular electrical motor, that's a geared motor, if you will, route in the past. And I even built a prototype using the readily available RC servo-based servos platform for 3DOF. But anyway, so what I'm looking at right now is to basically applying similar concept through pneumatics. I went to a local store here in Minneapolis and purchased these 4 they call Bimba Flat 2. These are miniature-sized pneumatic actuators, and this is a 4-port relay controllable switch that can control these 4 actuators. So the whole point of this project is really to prove a concept that I could use this at a low cost in my home cinema room. I'm not looking at building a simulator for gaming. I'm not a gamer, so I would be a very bad gamer if I were to be building one. But anyway, so what I'm looking at building is a home cinema room. When you're sitting on a couch, rather than just shaking the couch using readily available products in the market, like for example, there is a product called Kick Butt, or Butt Kicker, I think it's called. It basically feeds off of a subwoofer signal and then vibrates your couch. So you get that added experience when you're watching movies like, let's say, Star Wars or Jurassic Park, action-filled movies, which is great. And in fact, I have a variation of that product in my cinema room. It works really well, and it feeds off of your subwoofer line, and then there's an amp that enhances that input and feeds that to this device that I'm talking about. But what I'm building here is actually an actuator. So in a home cinema environment, we don't need too much of vertical motion. We want the feel, an ever so light experience where your couch goes up and down maybe an inch or an inch and a half on each of the 4 legs. So you could accomplish that with these actuators. They have a vertical travel of about, let's see if I can pull this up, of about an inch, maybe an inch and a quarter, and which is plenty good for a home cinema room. I believe at 125 psi, I did some calculations on the barrel size, the piston length, etc. And at a 125 psi, this individual actuator can carry approximately 200 pounds, right? And so I'm not quite sure if these would be the actual actuators I will use in my home cinema room, because obviously I have a couch in my home cinema room, which is by itself is quite heavy, and then when you have audience sitting on it, let's say two of them approximately, let's say a total of 400 plus two, about 600 pounds worth of weight. It might be a little bit of a challenge for these actuators to carry that and be performant. With that said, though, what I'm looking at doing here is to prove the concept. And in this plywood, I'm just laying out the actuators so that I can show the motion through controlling the relays and then through the switch and see how it works. And once it's, I want to use this for my programming and for my Q design and things of that nature, which I'll go into a little bit more. But basically, I want to use this as my prototype before I expand the concept to my home cinema room. So really, that's the intent. The way these work is fairly straightforward. These actuators have an inlet and an outlet. Or actually, let me put it this way. The actuators have two ports. The bottom port, when you apply pressure to it, the actuator goes up, or the piston goes up. And when the pressure is applied to the top port, the piston goes down. And the idea is when you have some payload on these four actuators, the weight by itself will push the actuators down, and the upward pressure is what causes the actual experience, so to speak. So really, that's the intent. So let's suppose. So that's a quick concept, by the way, before I move on. The switch here, the top ports here, can act as the upward motion outlet, and then these could be the outlet for the downward motion of the actuators. And then this is where you provide the, let's see if I got this mini air compressor here. By the way, that can get pretty noisy. But anyways, that gets fed into here, and then think of this as your noise silencer, because when the air pressure feeds back from the actuators, that air pressure exits through the silencer, and the silencer dampens the noise a little bit, if you will. It won't completely dampen, but it does a little bit. However, for the prototyping, I'll probably have this compressor right by me or somewhere in that area, just to reduce noise while I'm shooting a video, as an example. But in real-time environment, in production environment, that compressor would be sitting somewhere in the garage, and then there would be a line coming in to the cinema room, feeding to it, and then have it function. Okay. All right. So that's the mechanics of it. That's the idea behind this project. Now, one other thing I will quickly mention here. And I can go more detail in my part 2 or maybe part 3, is how do we actually control which of these actuators goes up and down based on a movie you're watching or a movie clip you're watching. So let's take a classic example of Star Wars, where you have the starships chasing each other, and then they go down and up and through the mothership, if you will. That scene has a lot of action packed in it. What we could do, or what I'm planning on doing, is as I watch that clip, just that clip, you could build a Q file. So using, and I'll go through this in my part 2 of this video, where I'll show you a program I wrote in C# using Microsoft Xbox controller joystick, and then basically building a Q file. A Q file is nothing more than, hey, what is a timeline? In a given timeline, which actuator is going up and down and for how long? So basically think of a Q file is a marriage of a timeline with the notes for or commands or status of each of the actuators, if you will. So let's say when the scene starts, you want all of these pistons or actuators to be up. So when the scene starts, the Q file will contain at 1 second in the timeline, all of these actuators would be activated, so they are all upward. And then as the scene progresses, you can build a Q file so that the front two actuators are lowered, the rear two actuators are elevated, so you have the forward going degree of motion. And then you could go, the left two will be down and the right two will be up, so you have a leftward motion and the rightward motion and a backward motion. It could also be a diagonal motion in the forward left, and diagonal motion in the forward right, and diagonal motion in the rear left and rear right, if you will. So those are the simple Q elements that you can capture as you build a Q file, and I'll show more of that in my part 2 of this video. At this point in time, I just want to kick off the project. I think there might be some interest in people, to follow this project. I will be building the Q file using my Windows PC with my .NET application, and then I will leverage my my Raspberry Pi to actually control or to actually play the Q file once the Q file is readily available. So a typical workflow would be, hey, I want to watch a Star Wars clip. Before I watch it, I would synchronize the Raspberry Pi to play the clip, but before it plays the clip, it also loads a Q file, and then it synchronizes the play of the video clip with the Q file so that they are in sync as they get played. So you get the motion to marry with the video, the visual. So really that's the intent of it. By the way, these relay switches require 12 to 24 volts, I believe. I'm planning on using one of my batteries there to marry up. Maybe it'll sit somewhere on the board for now, and really that's it. And I right now wired up, lined up the upward pressure line or air line, and then I will be lining up the downward air line as soon as I'm done with this portion of the video. Anyways, thank you so much for watching. These are not, by the way, these are not quite glued in yet to, not screwed in yet to the board. Just for the purposes of this build out, I super glued them to the board temporarily, but I will be drilling holes so that I can secure them to the board. Same thing with the switch here. And thanks for watching. I'll keep you guys posted. In my part 2, I'll show you the .NET app that I built that builds out the Q file, and I will then switch back to this section here, to the hardware portion of this here, and show you a quick working demo. I'll eventually have some sort of a plank or a board that sits on top of the 4 actuators here, so you can actually see it work, go up and down with some payload on the top. So the payload itself will act as a downward pressure to these actuators, so we can see it in real time. Alright, thank you so much, and we'll talk soon.